Hi everyone. So today I'm going to be talking about rational equations and how to just making them simple. Think about if you were driving to a friend's house, and let's pretend you live here and your friend lives here, and there's roads that you could do. You could go like this to your friend's house, and then there was a road that went directly there. Which route would you take? Well, I guess some of you might be joking now and saying I might take the long route if I'm trying to gain up hours while I get my license, but I'm guessing you want to get there as fast as possible, so you're going to take the most direct route. You're going to make it simpler. So that's what I think about when I solve rational equations. Rational equations involve fractions, and one of the ways that we should always make equations simpler. You can only do this with equations, which means there has to be an equal sign, is to clear the fractions. Clear the fractions. Now, how do we clear fractions? Well, we clear fractions by multiplying every term of the equation by the lowest common denominator. What can be tricky here is what is the LCD in a rational equation? Well, think of each one of the denominators, each expression as its own factor. And even if I put this over 1, there's actually a factor of 1 there. So you need each factor the most times it occurs. So x minus 2 is a factor, so it's part of my LCD, okay? And x plus 2 is also a factor, so it's also part of my LCD, okay? All right, so what do? I multiply the entire equation, or every single term of the equation, and if you want, you can actually do it in parts. If you want to, you could do this. Multiply this by x minus 2, x plus 2. Multiply this one by x minus 2, x plus 2. And multiply this one by x minus 2, x plus 2. That's actually what you're doing. Now, this is to get rid of the fractions. Some of you keep wanting to make the denominators the same, so multiplying by what's missing. And that's just a lot of writing. It's not going to get rid of the fractions. And if you're like me, I don't really like dealing with fractions if I don't have to. So watch what happens. Think of each of these LCDs as over 1, and that might help too. Then I can simplify the fraction by canceling out the x minus 2's. So what am I left with? I'm left with x plus 2 times x. Plus. All right, move on to the next one. The x plus 2's will cancel, and I'm left with, I'm going to actually put the 30 in front, 30 times x minus 2. Now on this side, it's a little bit trickier because I don't have anything that cancels, so I actually have to do 9 times x minus 2, x plus 2. All right, so now no more fractions. So the equation's already simpler. Now I have to work with each side of the equation. Now we have to do our order of operations on each side, so I'm going to do the multiplication here. So that means I'm going to distribute the x, and I'm going to get x squared plus 2x. Here I'm going to distribute the 30, and I'm going to get plus 30x minus 60. And then I'm going to combine everything, so I get x squared plus 32x minus 60. All right, now I'm going to work with the other side of the equation. Hopefully you're starting to recognize that really critical factor pattern, that this is the difference of squares in factored form, which means you don't have to FOIL, you don't have to multiply the inner and outer terms, you only have to multiply the firsts and the lasts. That would be x squared minus 4. So now I have 9 times x squared minus 4, which is going to give me 9x squared minus 36. Okay, so here we are. We're at 9x squared minus 36. Hopefully you're now recognizing that this is a quadratic equation. Why is it a quadratic equation? Oops, what happened? What happened? Why is it a quadratic equation? It's a quadratic equation because the highest exponent of the equation of x is a square. So I'm going to subtract x squared to both sides. I'm going to subtract 32x, and I'm going to add 60. So subtract, I know I got kind of messy there, but so I'm going to rewrite that. I get 8x squared minus 32x. What is that? 60 and 36, so plus 24. So plus 24 equals 0. All right, it's game time. I've got this equation. It's a quadratic equation. It's set equal to 0, and I notice that there is a GCF of 8. So I actually decided I'm going to divide every term by 8, giving me, because that's simplifying it even more. So x squared minus 4x plus 3 equals 0. And now that looks like something I know how to work with, a nice quadratic, so I can factor. I'm looking for the factors of a positive 3 that add to a negative 4, which hopefully you're seeing are 3 and 1. So I'm going to do x minus 3, x minus 1. Am I done? No, because the directions probably said solve, and I need to solve for x. So I'm going to use the zero product property, which tells me that each factor can be set equal to 0. So 3 is going to make this factor 0, and x minus 1 equals 0, so x equals 1. Okay, all right, so hopefully you're seeing how I got that, my two answers. Now I would want to go back and check to make sure both of those work. I also want to make sure that 3 and 1 don't make the denominators 0, because then they'd be outside the domain of the function, and that wouldn't be good. But in this case, they do both work. So my answers would be x equals 3 and x equals 1. All right, hopefully that helped, guys. Have a great day.